Lenz's law is a convenient method for determining the direction of induced current or EMF. It is not an independent principle. It can also be derived from Faraday's law. Lenz's law is based on the law of conservation of energy. This law gives the nature of induced EMF, or say the direction of induced current through the closed circuit. This law states that the nature of induced EMF, or the direction of induced current, is such as to oppose the cause of its effect. Read it once again. The nature of induced EMF, or the direction of induced current, is such as to oppose the cause of its effect. What is the cause of that? So we all know that the cause of this induced current is the magnetic flux. Let's understand Lenz's law more clearly with the help of these examples. Here in the first case, there is a closed loop, and a bar magnet is moved towards it. What do you observe? The direction of induced current in the loop is in anti-clockwise direction. What can be probable reason for this? The motion of magnet causes increasing flux through the loop. And now, if we have a look at the increasing magnetic flux, we can see the direction of magnetic field of the bar magnet is in this direction. Now, as the bar magnet moves towards the loop, the magnetic flux passing through the loop increases, so the induced magnetic field in the loop will be to oppose the field of the magnet, that is, in opposite direction. And to produce this field, the induced current must be anti-clockwise direction, as seen from the side of magnet. Now in the second case, the motion of magnet causes decreasing magnetic flux through the loop. So what do you observe? You observe that the direction of induced current in the loop is in clockwise direction. Again, the induced magnetic field is to oppose this flux change. So, as we can see here, the magnetic field of the bar magnet is in this direction. And as the magnet is moving away from the coil, the flux passing through the coil decreases. So, what happens is, this loop will try to maintain the magnetic flux through it. To produce this induced EMF, or say the direction of magnetic field that would be produced by this coil, will also be in this direction. Now, to produce this induced EMF, the induced current must be in clockwise direction, as seen from the magnet side. We can also understand these examples in another aspect. See in the first case, when north pole of a magnet is moving towards the loop. According to Lenz's law, what is its statement? That the direction of induced current is such as to oppose the cause of its effect. So, when the north pole of a magnet is moving towards the coil face that is towards the north pole also becomes the north pole. And as per the clock rule, the face of the coil becomes north pole when the direction of current that is flowing in it is in anti-clockwise direction. In the second case, when the north pole of the magnet is moved away from the coil will oppose the cause of its effect. So, this face becomes the south pole and we try to attract the magnet. So the direction of induced current through this coil, as from the clock rule, is in clockwise direction. When south pole of bar magnet is brought near the closed coil, the direction of induced current will be such as to oppose its cause. So, when south pole of magnet is brought steadily near the coil, the flux off the coil changes, and to oppose this, the direction of induced current becomes clockwise as seen from the side of the magnet. Again, when the south pole of the magnet is taken away from the loop, the flux through the loop changes, or say, decreases in opposite direction. So, to oppose this, the face of the loop towards the magnet start acting like a north pole. Or say, the direction of induced current is anti-clockwise.